Alright, hello, welcome to our first lesson for this small unit, and we're going to be looking at exponents. I want you to go ahead and pause the video and just try the warm-up on your own and then check your answers. Right here we have 5 times 5 times 5 times 5. So if we do that, we have 5 times 5 is 25, times 5 is 125, and then if we do 125 times 5, we get a final answer of 625. The next one we have 3 times 3, which is 9. 9 times 3 is 27. Here we have negative 7 times negative 7, which would be 49. And then we're going to take 49 times negative 7, and we get negative 343. And then our last one, we just have 9 times 9, which is 81. Hopefully you noticed from what we were doing is we were looking at repeated multiplication, which is going to lead into our lesson today, which is learning to evaluate expressions with exponents. So just as a review, remember an exponent represents how many times the base is to be used as a factor.
I don't know what you mean by use hours.
A power is a number produced by raising a base to an exponent. So both 27 and 3 to the third represent the same power because 3 to the third we found when we evaluated equals 27. So in our example on the bottom, the 2 is our base, and then the 7 would be our exponent. And then this whole thing would be considered our power. So basically what exponents do is allow us to shortcut or a quicker way to write repeated multiplication. So in our first example, 4 times 4 times 4 times 4 is the same as 4 to the fourth power. Negative 6 times negative 6 times negative 6, our base is negative 6, and it's multiplied 3 times, so it's to the third power. Now, you read negative 6 to the third power as negative 6 to the third power or negative 6 cubed. And we can do the exact same thing we did with numbers with variables. So here our base is x, and x is used as a factor 1, 2, 3, 4, 5 times, so it's x to the fifth. Same thing with d. D is our base, so it's going to be our big thing. It's used 3 times, so it's going to be d to the third. So why don't you go ahead and pause the video and see if you can do this next one on your own. Right here we have some mixtures of things going on. So here we have 5 as a base twice times d as a base 4 times. Now the 5 to the second we can actually multiply out. So another way we could write that is actually 25 times d to the fourth. Same thing here, we'd have 7 to the second times b to the second. Once again, we could figure out the 7 to the second is 49, b to the second. So now we want to go ahead and evaluate. So 3 to the fifth, remember, means 3 times 3 times 3 times 3 times 3. So if we go ahead and do that, the 3 times 3 is 9, and I would do also 3 times 3 is 9. 9 times 9 is 81. And now I can just do 81 times 3, which is going to be 243. Now on the second one, you'll notice that the negative 3 is inside parentheses. So this is the same as negative 3 times negative 3 times negative 3. In this case, we have negative 3 times negative 3 is 9. 9 times negative 3 is negative 27. Now, as a hint, it's always you always want to use parentheses to raise a negative number to a power. Because if you don't, it actually means something different than what you would think. So let's look at an example of what I mean by that. Here we have negative 4 to the 4th power, so the negative is inside the parentheses. So this actually means that we're taking negative 4 multiplied by itself 4 times. Now here, negative 4 times negative 4 is 16. Negative 4 times negative 4 is 16. So as a way to shortcut this, I could actually do 16 times 16, which gives me positive 256. Now in this next one, this is actually the same as negative 1 times 5 to the second. And since exponents get evaluated before multiplication, it's actually negative 1 times 25, which makes our final answer negative 25. So you do have to be careful about where that negative sign is placed. Now let's use an example of using the order of operations. So here we have x times y to the x minus z to the y plus x to the y. For x equals 4, y equals 2, and z equals 3. So here we're just going to go ahead and substitute in our values. So x is 4, and then we have y is 2 to the x power, so this would be 2 to the 4th, minus 3 to the y power, which is to the second, plus our x again, which is 4, to the y power, which is 2. We're going to go ahead and do our exponents first. So we have 4 times 2 to the 4th, which would be 16, minus 9, plus 16. We're going to do our parentheses, 16 minus 9, it's going to be 7, plus 16. 4 times 7 is 28, plus 16 gives us a final answer of 44. So you pause the video and try this one out on your own. Okay, so here first I'm going to substitute in, so z is 60 minus 7 times 2 to the x, so 2 to the 5th, minus 5 to our y power, which is 2. So here we have 60 minus 7, 2 to the 5th is going to be 32, minus 25, which is 7. So now we have 60 minus 7 times 7, or 60 minus, 49. Which gives us a final answer of 11. Alright, so let's just look at an example with some shapes. A four-sided figure has 2 diagonals, and we can verify that by sketching diagonals. So we can do that by just putting lines. So here we have 1, here we have 2. Same thing here. 1, 2 diagonals, because you draw them through non-consecutive sides. And then there's actually a formula that you can use to find the diagonals in a shape, which is 1/2 times the number of sides to the second power minus 3 times the number of sides. And this would be to find the number of diagonals in a shape. So if we're going to do this for a 7-sided figure, first thing we're going to do is substitute in 7. So we have 1/2 times 7 to the second minus 3 times 7. So we have 1/2 times 49 minus 21. So if we do 49 minus 21, we get 28. and half of 28 is going to be 14. So a 7-sided figure has 14 diagonals. Alright, here, so we have a lesson quiz. Just go ahead and pause the video, try this problem out on your own, and then just go ahead and check Edmodo to see if you can put your answer in. So population of bacteria doubles in size every minute. The number of bacteria after 5 minutes is 15 times 2 to the 5th. We want to know how many bacteria there are after 5 minutes. So here we're going to have 15 times 2 to the 5th. Well, 2 to the 5th is going to be 32. So now we just have 15 times 32. It's going to give us 480 bacteria.